The next phase of the disassembly will be to take apart the linkage of the constant speed governor. First, we will remove the lubricator from the governor connection. Then the pin must be removed from the spindle connection, and the fulcrum bracket, as the workman is now doing. The governor lever then slides easily off the valve stem connection pin. Don't forget to remove the pin from the governor valve stem connection. Don't lose any of these pins during disassembly. It's wise to provide a container to hold small parts, like the pins in the governor lever. We will not remove the connection from the governor spindle, but first, it's necessary to loosen the jam nut holding the connection in place. It's very important that you move the jam nut as little as possible from its present position. Loosen it only enough to get the connection off. You'll see why in a moment. Then unscrew the connection off the spindle. Now you can see why it is essential that we not move the jam nut any more than necessary. The workman is measuring the distance from the face of the jam nut to the end of the governor spindle. Once he obtains the measurement, he writes it down. The workman will be using this measurement when he reassembles the turbine later in the course. After the measurement has been recorded, the jam nut may be removed from the spindle. Our next task will be to disassemble the constant speed governor. First, the workman snaps the grommet seal out of the end of the governor hood and removes the grommet from the spindle. Then he slides the governor hood off the end of the spindle, as is being shown. This exposes the constant speed governor. Before taking the governor apart, we must record the distance from the face of the adjusting nut to the end of the governor case. This will enable the workman to replace the adjusting nut in the exact position it's now in. Record the measurement with the others taken earlier. Now unscrew the adjusting nut from the governor case and slide it back out of the way on the governor spindle. Once that's done, the entire spindle assembly can be pulled out of the governor case, as you can see. This assembly includes the spindle, governor bearing case, spring seat, and spring. You'll be able to see each of the parts better in a few minutes. The 3 weights still in the governor case must also be removed. To do this, these weight stops must first be taken off the case. It is a simple matter to unscrew the Allen head screws and place them in a container for small parts. After the weight stops are removed, the weights practically fall into your hand, since there is no longer anything to hold them in place. Be careful not to damage the knife edges as you remove them. Now that the weights have been removed, the workman will complete the disassembly of the spindle assembly. First, he slides the adjusting nut off the end, like this, and then comes the spring and the spring seat, as shown. We'll concentrate now on the other end of the spindle assembly. The part now being removed is called the governor bearing case. It is called a governor bearing case because it encloses the governor spindle bearing. By removing this nut and washer on the end of the governor spindle, the workman can slide the bearing off the spindle. That completes our disassembly of the constant speed governor. The governor case itself will be removed from the end of the turbine shaft in a few minutes. First, however, the rotating assembly must be removed from the turbine case. The workman positions his slings very carefully on the rotor, so it will be well balanced as it is removed from the case. Once the slings are in position, the workman raises the rotating assembly about an inch out of the bottom halves of the bearings. Now that the weight of the rotating assembly has been lifted off the bearings, the workman can roll the bottom halves of the bearing liners out of the housings, like this. He places them with their mating top halves. After the bearings are removed, the workman lifts the rotating assembly the remainder of the way out of the case. He is very careful to keep the assembly level at all times, preventing damage to the buckets and wheels. He then places the rotor in a cradle for the remainder of the disassembly process. The next phase of disassembly concerns the overspeed trip pin in the governor case. As you can see, the workman is measuring from the face of the adjusting nut to the end of the trip pin. He will then record this measurement for use later during reassembly. The first step in removing the pin after the measurement is to remove the U-lock staple, which locks the adjusting nut in position. You can then unscrew the adjusting nut and remove it, along with a washer and the spring which fits over the trip pin. Place them in a suitable container. The workman then turns the shaft 180 degrees and removes the U-lock staple holding the opposite end of the trip pin. He can then pull the trip pin and the auxiliary weight, if so equipped, out of the hole in the governor case. The overspeed trip pin assembly is now completely disassembled. The next step in the process will be to remove the entire governor case from the end of the turbine shaft. The case has an interference fit with the shaft and is also locked in place with a set screw, which the workman is now removing from the case hub. To remove the governor case from the shaft, it will be necessary to heat it until it expands. Before doing this, it is very important that we protect the rotor locating bearing from the heat. The sheet of asbestos we are using will also protect the retaining ring, which holds the bearing in position. The workman then uses a torch to raise the temperature of the governor case hub as quickly as he can. Do not heat the case hub slowly. If you do, the shaft will also expand, and you will be unable to pull the case off the shaft. On the other hand, applying too much heat too fast could damage the hub. It's best that your instructor demonstrate this procedure for you before you attempt it yourself. After the governor case has been heated sufficiently, slide it off the shaft, being careful not to burn yourself in the process. After the governor case has been removed, the workman removes the heat shield from the shaft. He then removes the retaining ring that secures the rotor locating bearing in place on the shaft. The bearing itself is then removed from the shaft, using the method of removal approved by your plant. Now that the governor case and rotor locating bearing have been removed, it is a simple matter to slide the oil rings off the shaft. Don't forget to remove the rings on the inboard end of the shaft also. During the next phase of our disassembly, we will completely disassemble the constant speed governor valve. First, the workman breaks the jam nut loose that holds the connection on the valve stem. Again, do not move the jam nut any more than necessary. Once the nut is loose, remove the connection from the valve stem. After removing the connection, he measures from the face of the jam nut to the end of the governor valve stem. This procedure is identical to that performed on the governor spindle earlier in this segment. He records the measurement for use during reassembly of the turbine. The jam nut can then be removed from the governor valve stem. The next step in the disassembly of the constant speed governor valve is to remove the cap screws in the cover, as the workman is now doing. After the cap screws have been removed, he slides the cover off the stem like this. The stem and valve can now be easily removed from the steam chest, as shown. A careful inspection should be made of the valve stem guide. Wear or damage should be noted. It's time for another measurement, this time of the diameter of the valve the workman just removed. Record the measurement for use later. The packing nut, or follower, as it is sometimes called, must also be removed from the governor valve cover, along with the packing itself. The next phase of disassembly is of the overspeed trip valve assembly. To begin with, the workman is disconnecting the spring from the resetting lever. He then unscrews the lock nut from the overspeed trip valve stem, like this. The upper spring seat, spring, and lower spring seat can all be lifted off the valve stem as one assembly. After the spring and spring seats have been removed, the bushing is exposed. It also must be removed from the valve stem. Now loosen the set screw, which locks the anchor pin in the end of the resetting lever. After the set screw is loosened, the anchor pin can be tapped out of the lever, freeing it. The resetting lever can now be moved out of the valve stem connection block and lifted off the stem, as the workman is now doing. Before going any further in your disassembly, remove these guide blocks from the resetting lever and place them in a container. Since they are not held in place, they could fall out and become lost. Another measurement must now be taken. This one is the distance from the top face of the valve stem connection block to the end of the valve stem. Record the measurement for use during reassembly. After your measurement is completed, remove the valve stem connection block from the valve stem, like this. Our next step is to remove the auxiliary resetting lever. However, before you can do this, you must remove the locking devices, which hold the lever to its bracket. Now you can slide the lever out of its bracket. As you can see, it also includes the return spring. Next, remove the cap screws from the cover of the overspeed valve and lift the cover off, sliding it off the stem. Since the cover is now off, the trip valve and stem may be simply lifted out of the housing, as shown. There is also a steam strainer in the inlet steam line to the turbine. It can be removed by removing a cap screw. To remove the hand trip lever, the workman must remove the snap ring that secures the lever to the pin protruding from the outboard bearing case. He can then remove the hand trip lever and its torsion spring, as shown. With the shaft removed, the workman can easily slide the trip plunger out of its fit in the casing, like this. There is one final step in the disassembly that is often forgotten. This is a leaf spring. The workman is removing it from the bottom of the rotor locating bearing fit in the turbine case. The leaf spring maintains pressure on the bearing, holding it in place. That completes the disassembly process for this particular turbine. As you have seen, it is a long and exacting procedure, which would seem to be impossible to remember. Because of this, we have inserted a step-by-step procedure of what you have seen in the back of your workbook. Use it whenever you have a question or are unsure of yourself. Again, let us remind you that you do not have to follow the steps we have shown you in the exact order shown. Deviations can often be made that will not affect the operation in any way. However, there are reasons that we have completed the disassembly in the order shown, and you will learn these reasons once you try it for yourself. Now turn to exercise number 3 in your workbook.